Hello, everyone. Today we're going to be continuing with our statistics unit, and we're going to be talking about some calculations that we're actually going to start working with data for today. And we're going to be calculating the central tendency, different values for how spread out your data is, and something called the 5-number summary. So the first things that we're going to talk about are the measures of center, or we call this central tendency. And these are the 3 different ways that we can calculate the middle of the data set. Now, eventually, at some point, you're probably saying to yourself, well, why do we have 3 different calculations? Well, sometimes for certain data sets, one of these is more accurate than all the other ones are. And we're going to look at that a little bit later in the unit. But for today, we're just going to focus on calculating these things. So let's start with the first one. The first one is the mean of the data set. And this is simply just the average of your data set. So to find your average, first we need to really work with an actual data set. So let's give us an example of one. So let's say we have the data set 2, 3, 4, 5, 6, 6, and then 7. Let's say that's our data set. All right. Now, I don't know what those numbers represent because I'm just making them up. But if we were going to go ahead and calculate the mean of that data set, what we would do is we would average them out. And how you average something is you just add everything up. So all of the individual data points, and then we divide by the number of data points that you're adding up. So we have, let's see, we have 1, 2, 3, 4, 5, 6, 7. So we have 7 total data points that we're adding, and we would calculate that out. So if I do 2 plus 3 plus 4 plus 5 plus 6 plus 6 plus 7, and I divide that all by 7, we get our mean to be about 4.71. That is one of the approximate middles of this data set. Now, that's not the only measure of center that we can do. We can also find something called the median. And this is, obviously, it's the data point that is in the middle. So here we don't have to add up anything or divide anything. Here, to find my median, it's simply just we're going to look at our data set. Now, for the median, there is kind of a requirement for this, and that is that your data set has to be in order. So your data set, your points can't be like out. It has to go from lowest to highest in order. And all we have to do is find our middle point. So if we kind of work our way in, usually I just use the cross-off method. So 2 and 7, 3 and 6, 4 and 5. And the number that we see here, that means 5, would be our median. Now, if we would have had a data set where it had been even, so like let's say we had another data set here, and I said find the median. Well, you would work your way in, 1, 1. And if there's a tie, this is a case where you would add them together. We would average them. So we'd add them together, divide by 2, and our median in that case would have been 5.5. Now, it wasn't because that 8 wasn't really included in our data set. So 5 is going to end up being our median in this case. Now, the last data set, the mode, this is the one we use the least, which is ironic because the mode is literally the data point that appears the most often. So if you look at your data set here, let's see, is there a value that repeats more than all the other ones? Well, the answer is totally yes. We have 2 6s in this case. So our mode of this data set would be 6. Now, if you're just comparing them, you probably are going to notice that they're all pretty different. And like I said, there's ways to choose there's ways to determine which one is the most accurate. We'll get to those later. Now, calculating the middle of a data set is obviously one of the most common things that we do. One of the other most common things that we like to calculate is something called the measure of spread, which is simply just how far apart your data points end up being, like what range of numbers you end up covering. And that's where the first one kind of comes into play, where we calculate what's called the range of the data set. And this one's pretty simple. It's just the difference. It's the difference between the largest and smallest data points. So if we were going to use our example from above, if I was going to find the range of this data set, we would take the highest, which is 7. We would subtract 2, which is the lowest. And that just means our numbers span a total of 5 different numbers. So we go all the way from 2 to 7. There's 5 individual unique numbers in here. Now, range is not the only difference that we can find. There is something called the standard deviation. And there's always a symbol that usually represents standard deviation, and it's sigma. So it's like a little O with a tail. But this one is not something that we're going to calculate by hand. This is something we're actually going to use the calculator for, because finding the standard deviation is pretty ugly. But what is it? It's just the average amount by which each data point differs from the mean. So if we look at it has something to do with when you calculate the mean of the data set, it's how far on average each data point is from that point. But that, like I said, that calculation isn't quite as easy. So we're going to do that one in the calculator. So one of the things that we're going to do then is kind of to prepare for some of the graphs and things later on in the unit. We're also going to be calculating something called the 5-number summary, which is the minimum of the data set, the Q1, which if you look down below, this is just the median of the lower set of data. So for example, if we were going to calculate our Q1 from the data set above, I'm just going to copy it down. So we had 2, 3, 4, 5, 6, 6, and 7. So obviously we found our median, which was 5. So if I focus on the lower half of the data set, we would find the median of this guy. So I'd work my way in. There's only 3 numbers, which means the middle number of the lower half would be 3. That means our Q1, which just stands for quarter one, it just means that it's the lower half, the median of the lower half. It would be 3. And obviously you can probably start to imagine when we talk about median is our Q2. That's the middle. That's what divides your data set into 2 different sets. So that is the Q2. We usually just call it the median. But then the Q3 is just the median of the upper half of the data set. So here, that's when we would now focus on the second half of the data set. And we would find our median, which in this case ends up being 6. So it's 6 would be our Q3. Now the last measure of, and this actually, just so you guys know, this is actually a measure of spread too. And this is something called the IQR, which stands for the interquartile range. And it's very similar to range, where range is the difference between the largest and smallest data points. The IQR is the difference between the quartiles. So I would take Q3 minus Q1, and that's how we would find our interquartile range. So if I was going to find my IQR here, we would take my Q3, which is 6. I would subtract my Q1, which is 3. And my IQR would end up being 3. So what I want you guys to do is if you go to the next page, I want you guys to try and find the 5-number summary of that first application problem. So pause your video now and give it a shot. All right, answers are up. So let's see how we got some of these values. So to find our min and max, these 2 guys are probably the easiest ones to find because the min and the max are just the highest and lowest values. I know I didn't talk about that, so I figured I'd mention it now. Sorry about that. But my min is the lowest number, and then your max is the highest. Now to find your Q1, your Q2, which is just really the median, and your Q3, this is where now we have to start dividing our data sets. So I started working my way in on the data set. And since we have a tie, that just means to find my median, we're going to add them together and we are going to divide by 2. And that's actually how we get our median of 17. Okay, so that's how we get this piece right here. Now, once you find your median, now we're going to find that's the halfway point. So to find your Q1 and Q3, we're going to now work with the individual halves of the data. Now you're going to notice that this one, because we had a tie, because 17 was the median and that's in between that 16 and 18, when you calculate your Q1 and Q3, those two values get kind of pushed into the individual halves. So if there had been an even number, like let's say just for fun, let's say this value hadn't have been there. When we work our way in and we find our median, if there actually is an odd number of data points, you actually reach a true median. You don't have to find an average, in which case 16 is just excluded. And then you just do your Q1 and your Q3 with all the numbers that are left. But obviously that didn't happen for us. So that's okay. That just means that because 17 is my median, I'm just now going to look at the numbers that are in the lower half, and we're going to find the median of this half of the data. Now, again, I actually do kind of have a tie in this case. So again, to find our Q1, we're going to add those together and divide by 2. And that's how we got our 13.5. Similarly, to find my Q3, I'm going to find my median of my upper half of my data. We tie. So again, add them together, divide by 2. And that's where you get your 19.5. Now, the next thing I want you guys to try and find are some of the measures of center. So I want you guys right now to find the mean. I want you guys to find the median. And I want you to find the mode and go. All right, to find your mean, median, mode, answers are up. To find the mean, all you had to do is add up all 12 of these values and then divide by 12. And that's how you get your mean of 16.33. Median, I don't know why I said that. We already calculated the median, but the mode, this one's a little bit weird in that we actually have 2 modes. Now, mode is obviously the one that occurs the most. So if there's kind of a tie, here we have 18, which shows up twice, and 20, which shows up twice. That just means both of those would end up being your mean or your mode. Now, if you would have had something like, let's say, for example, like this, oopsies, like let's say this 18 was gone and one of the 20s was gone. And you have a scenario where none of the values repeat. That's a data set where you just would have no mode. There's no value point that occurs more than all the other ones. So you would just say none. Okay. Now, if you guys look down below, it does say we're going to do this in the calculator. We're going to tackle that a different day.